In communication systems, we often talk about modulation, modulating a message signal. So what does it really mean, and why do we do it? Modulation basically means to take your message signal, your baseband signal, which contains the information that you're trying to communicate across the channel, and to use it to modify a high frequency carrier signal. So in the end, what you'll be transmitting is the carrier signal. So suppose you had your voice that you wanted to communicate across a channel to another party. What you would do is, instead of sending that voice, you would use it to modify a certain high frequency signal and thereby store the data of that baseband signal into that high frequency signal, and then you would transmit the high frequency signal. The other party, what they would do is they would receive that signal, demodulate it, do the reverse process, and then they would receive your voice in the end. So why do we go through this entire process? Why can't we just send the voice over the channel? This is for three reasons. So modulation has actually three purposes, and in the end they all seek to enhance the transmission. First of all, it's for efficiency purposes. We can't really send someone's voice over a channel. Now imagine channel could also be air. You would have walls, so many obstacles along the way. If you were to send someone's voice across the air, then along the way it would degrade, be attenuated, and in the end it would never reach the final destination. So what you would do instead is use your voice to modulate that high frequency signal, which is quite strong and very powerful, that it could make it across this medium and get to your final destination. And also these high frequency signals are very amenable to being transmitted over wires, copper wires, and so on. Next is concurrency. By using these high frequency signals, we could also transmit different voices across various bandwidths. So instead of operating just around the voice's bandwidth, which is the baseband, we would modulate the voice to different frequencies. So suppose we wanted to transmit a lot of people's voices. If we were to just use this bandwidth, it would be impossible to send all of the voices. What we do instead is take one's voice and modulate it to this frequency, then take someone else's voice and modulate it to a higher frequency, and so on and so forth. And the receiving parties will know which frequencies to tune to in order to get the message that they're trying to get. So it allows us to concurrently send various messages across the same channel. And finally, it's for practical transmission, practical purposes. If we were to send a voice which is in the baseband, then there is a rule of thumb that says your antenna, which is used for transmission and reception, would have to be as long as the wavelength of your signal. So in the baseband, the frequency is really low, so your wavelength would be really high. So basically you would need an antenna, and if you do the calculations, you would need an antenna that's about 100 kilometers long, and that's highly impractical. So what we do is we go to higher frequencies, and this allows us to use really small antennas that we could even store in small cell phones.